Lesson 10-3. Apply properties of chords. By the end of today's lesson, we'll be able to successfully use relationships of arcs and chords in a circle. Theorem 10.3 states that in the same circle or in congruent circle, two minor arcs are congruent if and only if their corresponding chords are congruent. So if arc AB is congruent to arc CD, then we can say that the chords AB and DC are congruent to each other. And I'm going to quickly describe the proof. So I can draw these imaginary lines to form two triangles. And apparently these are two congruent triangles by side. And by CPCTC, I can state that these two angles are congruent, and they also happen to be the central angles. And by definition of arc measure, arc AB should be congruent to arc DC. And for the full proof, please refer to my website. Example 1. In the diagram, circle A is congruent to circle D. Segment BC is congruent to segment EF. And measure arc EF is 125 degrees. And find measure arc BC. Well, since we have two circles here, and they have the same radius, so these two circles are congruent circles. Then they also have two congruent chords. So by theorem 10.3, we can say measure arc BC is equal to 125 degrees. Theorem 10.4. If one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So what this means is if segment QS is a perpendicular bisector of TR, so it cuts TR into two congruent segments, then segment QS, which is referring to the first chord in the theorem, is the diameter of the circle. This proof requires a little bit more time to explain, and you need an indirect proof for it. So I will leave it to you for you to read on my website, and I will explain it in class. And for theorem 10.5, it states that if a diameter of a circle is perpendicular to a chord, so then the diameter bisects the chord and its arc. So if EG is a diameter and EG is perpendicular to DF, then HD is congruent to HF, and arc GD is also congruent to arc GF. And I'm going to quickly tell you how to prove this one, and you can go ahead and look at the full proof on my website. I will also reinforce the proof in class. So basically you can draw the radius, label the center L, and draw another radius so that you form two right triangles, and you can prove that these two right triangles are congruent by the HL congruence theorem. And then we can say that this central angle is congruent to this central angle by CPCTC, And since this central angle corresponds to measure arc FG, and this angle corresponds to measure arc GD, then by definition of congruent arcs, they should have the same measure. Example 2. A journalist is writing a story about 3 sculptures arranged as shown below. Where should a journalist place a camera so that it is the same distance from each sculpture? First, we have to label the statues A, B, and C. I'll call this A, B, C. And then I'm going to draw segments A, B, and BC. Then I'm going to draw the perpendicular bisectors of segment AB. And the perpendicular bisector of segment BC. And by theorem 10.4, these would be the diameters of the circle containing A, B, and C. And I can go ahead and do this. And then I can find the point where the bisectors intersect, and this will be the center of the circle through A, B, and C. So this will be the center. And I could just sketch the circle. And I'm going to put in marks to represent what's congruent. So that's the radius. We use a different color. And that's it. Example 3. Use a diagram of circle E to find the length BD. Tell what theorem you use. So basically you have to use theorem 10.4. And because you have a diameter here, so it must bisect this chord BD. And you're already given the length of 6, so BD must be double 6, which is 12. Theorem 10.6 states that in the same circle or in congruent circles, 2 chords are congruent if and only if they are equidistant from each other. So AB is congruent to CD if and only if FE is equal to GE. For the full proof, please refer to my website and I will explain it in class. Let's first learn how to apply the theorem. Example 4. In a diagram of circle F, AB is equal to CD, which is 12, and we want to find EF. So by theorem 10.6, since these 2 chords, CD and BA, are congruent, we can conclude that EF is equal to GF. So I can set 3x equal to 7x minus 8. And this would be 2. X would be 2. So then I want to find EF. So I'm going to take 3 and multiply it by 2. And that would be 6. Example 5. If measure arc TV is 121 degrees, we want to find the measure arc of RS. By theorem 10.3, it states that if in the circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So since their corresponding chords are congruent, and I can say measure arc RS is also equal to 121 degrees. Example 6. Find the measures of arc CB, BE, and arc CE. Now I'm going to be real careful here. It's not the other way around. It's not the major arc. If it were referring to the major arc, it would be arc CDE. Okay, so by theorem 10.5, I know that BD is the diameter of the circle, and it's perpendicular to the chord CE, and then this diameter would then bisect the chord as well as the corresponding arcs. So I can set for x equal to 80 minus x and solve for x. And x would be 16. Then I need to take 4 and multiply by 16 to get 64. So since these two arc measures are the same, I can just do 64 degrees here as well. So let me first write my answers down to the side. This will be 64 degrees. And then CE would just be double 64, which is 128 degrees.